Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And I'm Brianna. For math homework help, call in Bakersfield 636-4357. Everywhere else is 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Brianna, if you took all of those numbers that are in the phone numbers, what would they all add up to? I'm only kidding, because there's a lot of sixes in there, right? Okay, because every kid that does that, they're like, oh, a lot of sixes in there. So where do you attend school and what grade are you in?
Stockdale Elementary, and I'm in 5th grade.
How is 5th grade?
Very nice.
It's very nice. Well, I'm glad you said that it is very nice. What is so very nice about 5th grade so far?
I mean, everything is easy,
Everything is easy.
I guess.
What have you learned this year that you think has been the most interesting then?
We are learning like directions with Y to X, and I think so far that's very interesting.
Okay, so you're doing X and Y coordinates, that's what you're doing right now? You like doing that?
Yeah, it's
Okay.
very easy.
Have you done anything with science this year that has been kind of interesting?
Not really.
Not really?
No.
Well, it's your lucky day because you're going to do something with science that's going to be pretty fun and interesting today. What about social studies or history?
Nothing. We've just been learning about like back in the past, like the American
Well, that's what
Revolution.
history is, right? Back in the past, okay? Have you been doing, let's see, I think in 5th grade is American history. Have you studied about the Revolution and things like that?
That's the main thing the entire year.
That's the main thing the entire year. All right, good. So is there anything that you think that you've done in math that you need a little bit more help with? Like you've done it, but you go, I'm not really too sure about that.
No.
Everything's been pretty cool so far?
Yeah.
All right, well, good. Well, you know what? I'm glad you're here because I've got some bonus problems for you today then, all right?
Okay.
Let's first take a look at today's problem of the day. This is a problem that is posted on social media, and kids and adults, everybody, anybody that wants to, can suggest their answer for this. Now, usually there are 4 options available, A, B, C, and D. But today I just wanted to put 2 out there, A and B. So have you ever seen a problem like that? Do you know what you would do first, or have you heard anything that goes with that type of problem?
I mean, not really, but normally we would start with like multiplication or division, then go if there's an addition or subtraction.
Okay, why would you do that? Like, why would you start with division or multiplication first?
Probably so we can get like the big problem out of the way and go into the simpler ones.
So you're thinking about start with difficult things first, then go to easier things.
Yes.
Have you ever heard of the order of operations?
I think so, but don't really remember.
You think so, but you don't really remember.
Yes.
All right, well, you know what? Here's what we're going to do. We're going to, you and Cindy are going to take 2 to 3 minutes. And what I'd like you to do is Cindy's going to introduce you to the order of operations on the board. All right, so head on over to the board quickly, ladies. And so Cindy, you know that Brianna doesn't quite know the order of operations. Okay. So in about 2 minutes, just kind of introduce her to the steps and we'll go from there.
Okay, so when you're approaching a math problem, your first thing is to start with any type of grouping symbols, which is often parentheses, but can also be you know, like brackets or other types of things. But since our problem has parentheses, I'm gonna write that. So you look for those first.
Okay.
If there's parentheses in your problem, you wanna do the inside part,
Okay.
all right? The next step is exponents, but you won't really have them at 5th grade level yet.
Okay.
So we're gonna write the next step that you would see, which would be multiplication or division. Here, to make it quicker, I'm gonna write. But here's the thing. When you do multiplication or division, you have to go left to right, kind of like you read a book. So if you see multiply first, you do it first. But if you see divide first, you do it first,
Oh, okay.
okay? And then add or subtract, same thing, left to right. So if you see add first, you do it first. If you see subtract first, you do it first.
Okay.
Some people get mixed up and want to always multiply first or always add first, but that's not the case. All right, so here's our problem, right? What
All
was
right,
it
so
again?
let's take a look at the problem, and you guys can actually write this up on the
Okay.
board. So let's go ahead and put it up there. So we have 6 divided by 2, and then open parentheses 1 plus 2. So come on back over here for a second, Brianna, because we're going to try to do this in our head, mental math.
Okay.
All right? So based on what you and Cindy just went over, what do you think is the first thing you might want to do?
Solve the problem in the parentheses.
Okay, if you did that, what would you get?
I would get 3.
You would get 3. And 3 is correct when you add 1 plus 2. So what would be the next step?
Next step would do the multiplication or division.
Okay, and we have both of those there, right? Because when you have 2 and parentheses next to it, that means you're going to multiply those two things.
Okay.
Have you ever seen that before in a math problem?
I guess, but they really add extra stuff to make it easier for us.
Okay, so we know that those two, when you see these parentheses, that means we're going to multiply these two things. Okay? But we have to multiply or divide first, going from left to right.
Okay.
So what do you think is the first step we need to do?
Of course, we divide the 6 by the 2.
Okay, so what is 6 divided by 2?
3.
Okay, and then you said this was 3.
Yes.
So what is, this again is,
A division problem?
right, that's 3,
Yes.
times, because that's what those parentheses mean. So what's 3 times 3?
It's 9.
Is 9. So
Is
you feel pretty good that 9 is the correct answer?
Yes.
Okay, so let me try this with you.
Okay.
Okay? Let's say we have 1 plus 2 is 3, right? And I say 2 times 3, right, because I'm going 2 times this. 2 times 3 is 6. Does that make sense so far?
Yes.
And if I go 6 divided by 6, I would get 1, wouldn't I?
Yes.
So which one do you like? Do you like 9 or do you like 1?
Oh, wait. 9.
You like 9? So you like 9 better than 1,
Yes.
okay? Well, let's take a look at the problem one more time. And this is what was out on social media. It had 6 divided by 2, and then in parentheses, multiplied by 1 plus 2, and the correct answer, Brianna is sticking with 9A, and is that correct?
I guess, yes.
Well, we're going
It's
to find
gonna
out
show
here
you
in a
right
moment. And there it is. So it is A, 9 is correct. But can you see how some people may have thought it was 1?
Yeah.
Because what they're doing is, you're saying 1 plus 2 is 3. They're doing the parentheses first,
Yes.
okay? And then they're doing 2 times 3 first, before this division. That's why a lot of people would get 1. Does that make sense to you?
Yes.
All right. So here's what I want you to do. Now that you have this newfound wisdom, head over to the board, and we're going to do another problem like this.
Okay.
You can leave everything up there, maybe just on the right side of the board, we're going to write this down.
Okay.
All right? So we have 3 times 4 divided by 2 plus 2. So you and Cindy go through that and let me know what you come up with.
All right.
Okay.
So we still have our order here. So do you see any grouping symbols?
Nope.
All right. So next you look for,
The multiplication sign or the division sign?
okay, and you want to go from left to right. So what are you going to do first?
Multiply.
Okay, so what do you get for that part?
You would get 12.
And I think we can move this. Does this go down? There we go, maybe a little room. Okay, so you got 12. And so what numbers did you use for that part?
3 times 4.
All right, so those two numbers are gone. So the rest of the problem, this part, is still back here. So go ahead and bring that part down, what you have left. Okay. So you did some of that step. Do you have any more for that step?
Yes, I have the division. So
Okay. So go ahead and do that part.
So I got
All right.
6.
So you got 6, and then what's left behind it still? Or
Uh,
what else is still in the problem?
The 2 plus, or the
Okay.
plus 2.
So go ahead and squish it in there or rewrite it. Okay, so now can you solve it?
Yes.
Because you only have one more thing to do, right? All right, good job.
Nicely done. So here's what I want you to do now. Leave that up there the way it is, move over to the left, and I want you to show a way that I could have gotten 3, but I wasn't really sure what I was doing.
So
I did
showing
it
an
wrong.
error?
Right.
Okay.
So you're going to do a little error analysis.
Okay.
So I want you to show me how you could get 3 with that problem,
I'm just
and
gonna rewrite
why
the problem.
somebody might think it would come out to be 3.
Okay.
So you and Cindy are going to work on that together.
So we're trying to figure out what did someone do wrong to get 3. All right. So, you know, we talked a little bit about what people sometimes have as errors that are common. So if you were approaching this problem and you're just thinking through this, what might be an error?
Not so quite sure, if I'm being honest.
Yeah. So, like, they might mix up which one of these to do first or which one of these to do first. So since we already did it, or you already did it with the multiplication first, try it with the division first, just to see if that could be possibly where people might mess up. Okay, so that would be like this part is 2, so then your problem would say that. That would just replace what was there.
Yes.
Okay. So if you finish that,
Then maybe someone would go to the multiplication.
okay. So go ahead and do that.
Okay.
All right, and then they're gonna do add 2, right? So go ahead and just put what it equals right back there, or put plus 2 in there. So it wouldn't equal 3 though, right? So that's not gonna be their mistake. It actually equals the same number, huh?
Right, comes out to be the same thing. So
Okay,
erase the 3 lines that you did to get 8, and we're still trying to find a way to get 3. Even though we're not doing it correctly, we still want to get to 3.
Okay.
all right. So how else might they have started?
Maybe they started with the adding.
Sure, because we already did that and that, so that's the only thing left, right? So.
Yes.
Okay. So then their problem would be like 3 multiplied by 4 divided by 4, because it would replace that part. Okay, so let's get 3 out of this. So what next?
I think multiplying.
Okay, go ahead. All right, and then do we have any more room? A little bit.
Okay, so now.
So then what's still left? So you did this, right?
And now we just have divided by 4.
Yeah, so you'd still have. And then
Okay.
you would solve it. Okay, and you get 3, so that's one way they could have made an error.
Right,
They
or
could have
they
added
could have,
4.
when you had 3 times 4 divided by 4, if they went 4 divided by 4, it would be 1. 3 times 1 is 3. You're still
Yeah,
getting
they
3
could have
right
also,
there.
right there, started
Right.
with that. You still get the same
Nicely
thing.
done. All right, come on over. There you go. So I wanted to make sure that you understood a little bit more about the order of operations and how you can do it and how you can come up with some different answers if you go in the wrong order. Does that make sense?
Yes.
All right. Hey, just a reminder, we do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Right now, time for today's Math in the News. Well, today's Math in the News is going to bring us back a little bit because we were at the East Kern Career Expo in Mojave on Friday, and let's check out what happened last Friday.
We have invited 50 vendors and all of the schools in East Kern County to come and really learn and experience what industries are like out here in East Kern. We have industries from all 15 California industry sectors for students to interact with professionals, to learn about what day-to-day jobs would be like, and to get information to increase their exposure to different industries in California.
So we have our mining programs, we have clean energy development for solar, wind, and geothermal. We have outdoor recreation.
You know, Kern County is #3 most diverse economy in the country, and a lot of that is due to the fact of what's happening in East Kern. So a lot of the students aren't aware of what's in their own backyard. There's different paths. Voc Ed's very important. So, you know, as they're in high school, they're working on various programs.
Well, if you're interested at all, as a high school student, you can actually take our cerebrocoastal classes online.
We're looking into aerospace right now. We have a welding program. We have an allied health and just things like that students can really kind of do a hands-on approach to their education and then learn about the pathways and different careers that they can look at.
Anything STEM related, we like to attend and show our simulators off, talk a little bit about what we do.
No!
Maybe becoming a pilot, maybe joining the Air Force. Maybe they're interested in planes and want to see all the mechanical stuff inside of a plane. So we're hoping to, you know, just ignite a little spark inside of them and get them interested in planes.
There you go. So we're gonna fly for 2 minutes.
It was really fun. The feeling was good. VR headset had a mod on it where it made it feel like air was hitting your face.
I'm a third-generation employee at US Borax. Started as a second-class mechanic right out of trade school, got into an electrical apprenticeship in the refinery, and then a supervisor, and now I'm a control specialist, so there's abundant opportunity for growth. We all want to see our kids succeed, so we push as parents for them to stay on top of their grades and do the things they have to do, but when they're evaluating, like my oldest, when he's evaluating what do I want to go to college for, if I do want to go to college, do I want to go to trade school, do I want to go to the military, what options are there? You don't know that unless you have these types of events, so that information getting out there is super important.
Study about it, research it, maybe come back here, ask about it.
You guys can have stickers and posters.
The National Training School, Flying School, how it's going to help you train to be a professional pilot so you can train how to drive a helicopter and a jet.
With the Kern County Superintendent Schools and all the districts in Kern County, we formed the Kern Education Pledge. And out of that Kern Education Pledge, it was a focus to really work with sectors beyond education to do what's best for our students and making sure that they get tools and the skills that are needed to be out in the next generation of the workforce.
And a great day out there in Mojave. That happened on Friday. You think that would be an event that you would like to go to sometime?
Yes.
Yeah, those things are happening all the time throughout Kern County. And the Kern County Superintendent of Schools is behind that, and career pathways and all of the different careers are what they're trying to bring to you guys so that you kind of get an idea like, oh yeah, I might want to try that, or at least start looking into these things. Have you thought about what you might want to do when you're through with school?
Most likely art.
Very nice. Any particular type of art, or you just art?
Just art.
Just art for now. All right. Well, you know what? There are a lot of different types of engineers. Did you know that?
Yeah.
There's tons of different types of engineers. Instead of just going, oh, I just want to be an engineer, people are going to go, well, what type of engineer do you want to be? So that brings us to our part 2 of today's Math in the News. Works systems engineers do overlaps and influences numerous fields of engineering and data science. An example is the Caesar cipher. Have you ever heard of this?
No.
Sweet, that's exactly what I wanted to hear. So we're going to go over this. So it was named after Julius Caesar. Have you ever heard of Julius Caesar?
No.
Okay, well, you know what? Big day for you then. All right, Julius Caesar is somebody you're going to learn about history, especially when you get in high school. I know that. So they wanted to send secret messages because you don't want everybody always to know what your plans are if you're in a battle.
Okay.
Does that make sense?
Yes.
So you want to have secret messages, secret codes, so that the person on your side will know what's going on. And if somebody got that by accident, they'd look at it and go, I don't know what this means.
Oh, that's
Okay.
smart.
So, but it is smart, right? So the Caesar cipher is right here, and it's a 3-place rotation to the left. So that's what this little abbreviation right here means. So you're moving each letter 3 spots to the left. So in A, if you go backwards from the alphabet, Z, Y, X, you go back 3, and A would represent X, or an X would represent A. Does that make sense?
Yes.
All right, so here we can see the alphabet written in that way. So you're just counting 3 backwards.
Okay.
So if I had O, if I went back 3, it would be at L, but it's also corresponding right here.
Oh.
You with it so far?
Yes.
All right, so let's take a look at one of these. So we'll see if you can decipher this, all right? So B, now we know that B is right here, and it corresponds to Y. Or we can see B is here, and it corresponds with E. Now, we see that there are a few B's in this first word. So do you think these B's are going to represent Y's or E's?
I think they might represent E's.
Why do you think E's?
Because most common letter or words use E's instead of Y's.
Excellent. That is what I wanted you to come up with, right? The most common letter used is the letter E. All right, and you're going to have a lot more words that begin with E and have double E's in the word instead of double Y's. Okay. So if this is E, then we know that we're starting down here. B will be represented with an E. So K, what would K?
K would represent H or
Well,
N.
remember, we're going to go from the bottom to the top because B was E, so now we're going to look for K.
N.
N. So we have E-N. So what would D be?
D would be G.
Okay. F would be
I.
K would be
N.
You got it, right? So what word do you think this is all going to be when you take a look at it all together?
Not really getting an idea.
Well, okay, so start spelling it out. E, N,
E, N, G.
I, N, E, E. O is going to be R.
Okay.
P is going to be S. So engineers.
Oh.
Right? Does that make sense?
Yeah.
All right, so let's go to a shorter one. You got the long one out of the way now, right? Engineers. So T.
T would be W.
Okay. And then a B.
Which would be a E.
Okay.
And then another E. And then an H would be K.
So engineers week.
Okay.
Right? Because this was math in the news because there was a lot of engineering stuff going on last week. So engineers week. So what's FP?
F was I, and then P is S.
So engineers week is the best. I'll just save you a little bit of time on that one, right? Because here's the bonus one for you. All right? So now this one, see if you can do this one all on your own.
I already broke out the first letter, and looking at how many letters there are, I think I know what it is.
What do you think it is?
Do the math.
Do the math. How did you get that so quick?
I just saw the first letter was D, and knowing this is do the math.
Well, there you go. See, that's using your brain right there, right? You're like, oh yeah, D, there we go. It works, but do the math. But you see how that cipher works.
Yes.
Right? So that's how you can send a secret code to somebody. And as long as you and the other person know that code, if somebody else looked at that, right, they would go, I don't know what this is. This is just nonsense to me, right? And they would try to figure it out, but it could be a lot of different things. But that is a Caesar cipher and today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. And are you ready for another problem?
Yes.
All right. Head on over to the board, young lady. We're going to have you do order of operations again, but this time Cindy is going to come up with the problem, and you're going to come up with some different operations to put in there.
Okay.
All right? So Cindy's going to come up with some numbers, and you're going to come up with some operations.
Okay.
Just random problem? Okay. How many numbers do you want me to put?
5.
Okay.
Hey, you're in 5th grade. Why not go with 5?
Yeah. Well, we'll put a 5 right there since you said 5.
Yeah.
And you're going to put some operations.
Okay.
I'd like to do one first.
Oh.
Let's put multiplication between the 8 and the 2.
Okay. 8.
Well, just go ahead and put it right up there.
Oh, okay. Yes.
And then what would you like to put between the 2 and the 3?
Adding.
Go ahead.
Sounds good.
Maybe then division. Nice. And then probably just include subtraction.
So you're going to have a pretty difficult problem right there. So let's modify this a little bit so that you don't come up with some weird
'Cause
numbers.
This part doesn't quite work, right? So maybe
So
just
how
change that
about
part.
instead of division, think of something else you would like to put there. Because otherwise I'm going to have to put some parentheses and brackets all around things for you.
Well, how about this? We could do this. Oh, no, we couldn't, because that's, you haven't done negatives yet, huh?
Right.
Just change it. It doesn't, and you can reuse these, or, you know, it doesn't have to be something different, because there's only 4 operations, so you want
Subtract.
subtract? Okay.
Now, do we solve it?
Go ahead.
Okay, so there's no parentheses, so we do multiplication first.
All right.
8 times 2 equals 16. And then we do after that adding.
Here, I'm going to help you. I'm going to teach you how to organize your work. So if you just kind of go like that, and then you just put what it equals right underneath, it'll save you room. So like you put 16 here, and then you just rewrite the rest of the problem.
Okay. 16.
And then you can just like bring all the other stuff down.
Okay, and then we do the add 3 minus 4 minus 5.
All right. So you did all the multiplication and division. So you have add and subtract. Which one should you do first in this problem?
Adding.
Okay.
So 16 adding 3 would be 19. And then we bring everything else down.
All right.
Then we'll 19 minus 4.
Okay.
Had to work that out right here.
That's fine.
So I might as well erase it, so it saves me room and goodbye. So now I have 15 minus 5.
Okay.
Which is pretty obvious what the answer is. 10.
And 10. There you go.
Nicely done. So I just wanted you to get a little bit more practice with the order of operations, because hopefully you'll do a little bit maybe at the end of 5th grade, but you'll definitely do some in 6th, 7th, and 8th grade. You do tons of problems with the order of operations. And as long as you get a little bit of a taste of it right now, you'll get into more complex ones as you start doing them in class. Hey, we do have phone tutors available until 5:30, but right now we're going to check out a little bit about animation.
Well, it works.
2, 3.
Did you ever wonder who designed this flying dragon, making the wings look just right to soar? It takes more than artistic talent to create an animation like this from scratch. At every twist and turn, there's science involved.
I rehearsed this shot by spinning in my chair.
How am I gonna? I just need to. Every hop and skip requires an intuitive feel for physics.
It's not natural for a leg to bend this way.
Anatomy is a topic that doctors study, but so do artists. Now with animation, physics has become another science which is essential to the craft of these artists.
Physicist Alejandro Garcia is an advisor to animators at DreamWorks, helping them make dragons fly right and explosions look real.
When something doesn't feel like it's physically capable of happening, it pops the audience out. of the moment. It reminds the audience that what they're watching isn't real. You know, oh, I'm watching a cartoon. And that can really be damaging to the story.
This shot right here wouldn't work out in the real world.
So Garcia helps them create believable yet wacky worlds of their own.
Each movie, each film animation that we do has its own world of physics. Megamind's world wasn't necessarily our world.
If you have the character just moving side to side, then the stuff in the foreground is going to be moving much faster.
Garcia has developed a course at San Jose State University on the physics of animation. The idea is to teach animators in training how to make it all look plausible.
And you can stretch the rules, but you can never break the rules.
Do you have to remember, the smaller the object, the harder the shadows?
Learning these lessons could give these fledgling animators a leg up on the competition when they start vying for jobs in the lucrative movie, TV, and gaming industry.
It's a very highly skilled industry, and not every school is teaching it in the way that will set them up to succeed at a place like this.
Yes, I did it! Imagine what they will create with a little physics under their wings. For Science Nation, I'm Miles O'Brien.
Students probably wouldn't even think that you needed to know a little bit about physics to do animation to make that stuff look realistic and things like that, but you do need a lot of science and math in order to do, I would say, there's nothing in the world that you would be able to do productively that you don't need mathematics for. All right. Anyway, a lot about math. Anyway, Brianna is here with us, and we also are fortunate enough today to have Science for Kern in studio. All right, and from Science for Kern, we have Justin. How are you today?
I'm doing well. How about yourself?
I'm excellent, thank you. What is your role with Science for Kern?
So I am a STEAM program specialist with KCSOS, and Science for Kern are ready-built modules for teachers in the classroom, NGSS aligned kits that kind of will guide a teacher in the classroom through hands-on learning activities. And one of those activities we're going to do today, or actually what the module is based on, is energy. All right, so energy. Do you know about energy?
Yes.
Yes, okay, so first step, we're good. How about electricity?
Yeah.
Are you an electrical engineer?
No.
Have you ever been electrocuted?
No.
Okay, maybe today we can solve one of those things for you, okay? You ready? What we're gonna do is, electricity is just a form of energy, and energy is everywhere. Can you see any energy around us right now?
Everywhere.
Yeah, we have lights around us. We're full of energy. I'm full of energy. Are you full of energy?
Yes.
Okay, well, let's use some of that right now. So we're going to do something called squishy circuits. Have you ever heard of squishy circuits?
No.
Have you ever heard of Play-Doh?
Yes.
It's a really cool Play-Doh that deals with electricity. It conducts electricity, okay? So here's what electricity does. Electricity is kind of like water. It wants to flow.
Okay.
And it wants to flow in a circle.
Oh.
And when it flows in a circle, if you look back here, this is called a circuit, okay?
Okay.
And what we want to do is we want to use this energy from a power source. In this case, it's a battery, or our squishy circuit's a battery pack. And it's going to flow in a circuit, and it's going to move to something called a load, either a light bulb, a speaker, a buzzer, anything that needs to use up electricity. And it's going to light it up, and then some of that remaining electricity is going to flow back to the power source, okay? So we want this flow.
Okay.
Well, if we look down here to your squishy circuits, do you see our power source? Can you point to it? Okay, exactly right. Those are our power source. You can see their batteries back there. And leading out of here are two wires. One of them's the positive wire, and electricity is going to flow to that, and it's going to go into this squishy circuit, that Play-Doh. What's in between those two Play-Dohs?
It looks like a light.
Exactly right. It's an LED light. And what's hopefully going to happen, that electricity is going to flow to the light bulb. What's going to happen to the light bulb?
Turn on.
It's going to turn on. Some of that electricity is going to flow back and come back to our power source. Do you want to test it out?
Yes.
Okay. What you're going to do is press on, and let's see. Did we get it?
Yes.
All right. We just turned on a light bulb. Take that. Was it Thomas Edison? Who was the light bulb person?
Don't know.
Forget, that's why it was STEAM, not history. But he had that. So now we have a closed circuit. Everything's working great. Let's play around with it a little bit, okay? Play around in a safe way. Don't go home, just start playing around with electricity, okay? We're going to do it in a safe environment. I'm trained for this, and I'm going to help you. Go ahead and push both of those Play-Dohs together.
Okay.
What just happened?
It turned
Push it
off.
together again. Turned off. Here's what just happened. Electricity wants to take the quickest, easiest path. So when these were apart, when the electricity was here, where was it moving to?
Up here.
The bulb and then back down there. When we press it together, guess what? It says, oh, it's shorter just to go here. You know what that's called?
Short circuit.
That's a short circuit. It takes the shortest path, okay? It's also an 80s movie or a 90s movie. You should watch that as well. It's really cool. But in this case, it's a short circuit. Guess how we can solve that? You see that white dough there?
Yes.
That's an interesting dough. It's called an insulating dough. It does not let electricity flow through it. It blocks it. So if I didn't want the electricity to pass through these two Play-Dohs or squishy circuit doughs, what should I do? What should I put in between it?
The white dough.
Perfect. Let's do that real quick. Go ahead. And squish it together. And go ahead and put the light bulb back in there.
Okay.
There it is. We just solved a short circuit. Okay. Here's another cool thing about it. Take the light bulb, turn it. Put in the leads, just turn it around. There you go.
Okay.
Did it work?
No.
That's something called polarity. This electricity only wants to flow one way through the light bulb. So go ahead and turn it back around. Let's see if you fixed it. See, you're halfway there. If someone's at home with an electrical problem, they need to call you. You can earn a lot of money. We saw it at the East Career Expo, Eastern Kern Career Expo. Okay, let's add some other things now. Other things that use energy. We have a fan here, correct? Here's what I want you to do. Go ahead and hold the fan. And I'm going to plug these in for you. And again, the red goes to the red lead Play-Doh and the black with the black lead. And now we have a fan. Is it hot in here? You can go ahead and cool yourself down if you need to. There you go. I know the lights get hot in there. So again, same idea. The electricity's flowing through it and the fan. The other thing we have is, I'll let you plug it in this time to see what happens. What happened there? I think she got excited. She's speechless, out of words. Are you okay? It's a buzzer right on there. So this is a buzzer. The electricity goes through it. Now, do you want to hear that buzzer the entire time? No. You want to be able to control when it goes on and off, correct? And hopefully you don't want it on too much, okay? If this was my kids, they would have that on constantly.
Oh, no.
Actually, when they're talking, it sounds like that buzzer most of the time in my head. So it's okay. So we need to add a switch, and here's what a switch does. It doesn't let the power go beyond the switch unless it's opened or closed, okay? You've seen this all the time. When you want to turn on a light, what do you turn on? The switch, huh? Yeah, the light switch. So here's what you're gonna do. Let's take some squishy dough. And I'm going to have you unplug this one. So go ahead and unplug the red. Okay. Put the red in this squishy dough. We're gonna create a new, we're good? Okay, now we're gonna take the switch. And here, I'll go ahead and do that for you. We're gonna put the switch here. And we're going to put the other end of the switch here. And when we turn it on, now we have a switch. How's that?
Cool.
Cool. It's amazing, right? Okay, so now we have a problem though. And now that you're trained up on electrical engineering, you're all the way there, you're ready to design a whole electrical light show, right? You think you are? I think she's getting choked up with thinking about how much opportunity you're gonna have in your life with what I'm teaching you right now. When you design an electrical light show, can you thank me for it, please?
Yes.
Okay, perfect. All right, here's what I need. I need you to help me with this problem that I have. I created this monster a little bit earlier. Who's this look like?
Frankenstein.
It's pronounced Frankenstein.
Frankenstein.
Do you know where that's from?
No.
Have you ever heard of Young Frankenstein?
No.
Oh, I'm gonna quote Young Frankenstein this whole time. You're gonna know at least most of the quotes from it. Okay, it's a movie back. If you haven't watched it, you need to watch it. My kids love it and they're only in like kindergarten, second, third grade. Okay, this is Frankenstein. And you remember, what did actually the doctor named Frankenstein have to do to the monster to get him to come alive? Do you ever remember that?
Yes, he used electricity.
And used electricity, and that powered him. So I thought the same thing. I want my monster to come alive, and then when I put all this together, I know he's alive when the lights come on. I turn it on,
don't come on.
Not live. I have a problem here. Now, you've solved a bunch of my problems, okay? Do I have my leads going where they need to go?
Yes.
Okay, they go right here and here. If you remember over here, we had them going like that too. My Play-Dohs are touching together. What happened over there when those Play-Dohs were touching together?
The lights turned off.
Okay, how come? Do you remember what that was called?
Open circuit?
Open circuit is when we don't have it going along, so that is a case, so let's see. But I do have them both here, so we can eliminate open circuit. What else could happen?
Short circuit.
Short circuit. How did we fix the short circuit last time?
We put the white dough in the middle.
White dough in the middle. So if these are my two doughs creating that short circuit, what do I need to put in the middle?
The white dough.
Can you grab out some of that white dough and roll it in a thing, and let's see if that works. Let's see if you can get Frankenstein to come alive for us, okay?
It's alive.
Oh, now she's quoting young Frankenstein. I like that. Okay, now we're going to put the leads back on, okay?
Okay.
Now I must tell you, whatever I say, how much I may scream when this comes alive, how much I may tell you to turn it off, you do not turn it off.
Okay.
If you ever watch a movie, you'll like that. You'll like that reference. Here we go. I also put the buzzer because we need to make sure our monster knows when it's alive.
Here we go.
Is everyone ready?
I guess.
Are you ready for our monster to hopefully work? Now again, this is science. We don't know if it's going to work or not. You're going to throw the switch, and you're going to say your line if it works, okay? Because you've already practiced it. Here we go.
It's alive!
There it is. It's alive.
I know.
It's alive. What do you think's wrong with that one?
It's.
Here, so we can hear. What do you think's wrong with that one? What happened to the LED light over there when it didn't turn on and was plugged in? What did we have to do with it?
We had to flip it around.
Okay, go ahead and try it. She's an electrical genius. You're Dr. Frankenstein, and this is what we have. What do you think of electricity now?
Love it.
Love it, and did you get shocked at all?
Yes.
You did?
In my mind.
Oh,
yes.
in your mind. She was electrified in her mind. That's what we have today. That's energy. Thank you very much. Our monster is happy. We're happy. And are you going to go back and do some, maybe change a light bulb or something at your house?
Yes.
Perfect. All right.
Thanks for that, Justin. So if somebody wanted to know more about this, like if an instructor wanted some of these kits that you have readily available, they come with everything supplied, where do they need to go?
They need to go to for scienceforkern.org, and the 4 is not the word, but the number 4. So science4kern.org.
All right. Well, I do appreciate all of the young Frankenstein and Frankenstein. So Brianna would be like your Igor, I take it, with the finding the Abby normal and things like that. So,
Yes.
Nicely done. So thanks for that. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. And even better than that, and just as cool, every single week we get videos direct from the students at CTEC. Today, computer technology.
So my first day here, I was very shy. I was very to myself. One thing that I tell myself now in the future is just be confident. You know, there's nothing to be afraid of. Everyone here has common interest. Everyone here likes the atmosphere and the people around us. So just coming into it, I wish I had more confidence. I wish I got out of my shell a bit faster. I feel like that would have really helped me just develop faster and get to where I'm at now earlier.
Yeah, the computer technologies class, essentially it's an introduction to the world of IT. Students learn all of the fundamentals, what it takes to be in information technology, the hardware aspect of it, software, operating systems, networking, and then of course troubleshooting. So in addition to the technical aspect, we also practice a lot of soft skills that I feel are needed in IT. You know, a lot of communication, leadership, practicing empathy, because anyone that works in this field has to talk to people, so I really do put a focus on that. So
in the regular class every day, depends on the day. Most days, every kid will do labs to learn hands-on knowledge about what you're going to do in the field, what you're going to do if you continue down this pathway. But not only do they learn things that they'd use in the IT field, they'd also learn things that you'd use on the job site, whether it's communication skills, resumes, things of that sort. And some days you'll do hands-on stuff, whether it's computers, so fixing computer, diagnosing, reinstalling Windows, reinstalling different operating systems. So on the daily, usually it's either labs, learning not only in-person skills, but also skills that can help you in your field.
I would describe them as more of a family. You're here with these people for 3 hours every single day of the week if you don't have internships, but I would say we're really close with each other. Not everyone gets offended by what everyone says because we all know what we all mean. It's very close-knit, and I'm actually really glad to have these relationships.
As far as the community classroom part of it, the students do go out second semester and actually go and work at different sites. So we have a lot of industry partners all over Kern County. So we have school districts, we have Bakersfield College, and a lot of local IT companies that the students will do their internships with. I feel like the most rewarding part of teaching here is seeing the students grow over time. I have a lot of students that come in really not knowing anything about computers, just being afraid to even open a computer, see what's in it. So to go from there to actually taking apart a computer, putting it back together, learning all of the fundamentals, it's a very rewarding experience for me.
The most useful thing I've learned is probably troubleshooting. Troubleshooting is very important in this class in IT.
Honestly, what makes or breaks a student for this course is their willingness to be here. They have to show some effort. So, you know, if I have a student that just simply does not want to be here, you know, they are removed from the program. So honestly, it's just effort is what I like to see in a student.
What makes a great teacher is someone who is fun, but also engaged with the students, and very interesting.
The main thing that they take away from my class is not only learning the concepts, but just learning to just become better people overall. So even if they don't go into an IT career, at least that they're able to communicate better and, you know, gain a lot of those soft skills that can go with other careers. So that's important.
And learning about computer technology and all of the different courses that they have at ROC and CTEC are all produced by students at ROC and CTEC as part of their video class, and they produce all of those and send them to us. You think you'd like to work with computers when you get older?
Maybe.
Well, you're probably going to have to one way or another anyway, so. Are you comfortable using computers?
Yeah.
All right, good. How are you at organizing information?
Pretty good.
Pretty good? All right, well, let's find out, shall we? Got a problem for you right now. Let's take a look at it on the camera. Rachel wrote the names of her 5 fish on a piece of paper in a certain order from left to right. She put Spot before Shadow, but after Einstein. She wrote Rover after Einstein, but before Spot. She wrote Buffy after Rover, but before Shadow. If Buffy was not the third one listed, in what order did Rachel write the names of her fish? So, what do you think you're going to do about this one?
Probably organize them.
Probably organize them somehow? All right, well, you and Cindy head over to the board, and Cindy's already got the names of the fish listed for you in 5 little spots. So instead of writing out the whole name, you could probably just put the initial. Okay. And for Spot and Shadow, we'll just go SP and SH instead. So however you guys want to do it. All right? So let's take a look at all of because you're going to need all of this information.
Okay.
So let's take a look at it again. She put Spot before Shadow, but after Einstein. So Spot goes before Shadow, but after Einstein. So just deal with those 3 first.
So for those 3, who would have been first? Who would have been last? So let's start with just the Spot before Shadow.
Okay, so that means Spot before Shadow.
So let's just like maybe up here, just organized. Okay.
So I think.
So write down SP for Spot. Now, before Shadow, so where would Shadow go?
Maybe before.
So Spot before Shadow, should we write Shadow in front or on after?
After.
Okay, so just write SH over there. Okay, and then it said, but after Einstein. So where would Einstein have to be then?
So Spot is after Einstein.
Then that would be Einstein over here.
Okay. So an E for Einstein. Okay, so that's the first part.
Okay, so she wrote rover after Einstein, but before Spot.
Okay. So rover, where's rover going to fit in if he's after Einstein but before Spot?
Right here.
All right.
So we would
Do you want to maybe just erase it and scooch it over to give a little?
Okay, and then that would mean rover would go here, and then Einstein would be over here.
Okay.
All right, let's take a look at the clues again. So we're now at, she wrote Buffy after Rover, but before Shadow. So Buffy is after Rover, but before Shadow.
So here's rover, here's Shadow. She's somewhere in here, right?
So that would mean she would come before Spot.
But we don't know that for sure. Let's read the next part of the clue first. So we know she's somewhere in between.
If Buffy
here,
was
right?
not the third one listed, what is the order?
There we go. That helps us.
That would mean Buffy would be after Spot.
There we go.
So we would have to move Shadow. Oh, was it a circle? Sorry.
We got Buffy.
And
then put Shadow back on there.
There you go.
All right. So are you confident in your order now?
Yes.
Okay. You want to just fill in just the initials.
E for Einstein, then Rover, then Spot, and then Buffy, and then Shadow.
All right, so let's take a look at the whole thing again and make sure that everything works that you've got written down now.
Okay.
So, she put Spot before Shadow. Is Spot before Shadow?
Yes.
But after Einstein.
Yes.
Okay. Rover after Einstein. Is Rover after Einstein?
Yep.
But before Spot.
Yes.
Okay. Buffy after Rover,
Okay.
but before Shadow.
Yeah.
Buffy cannot be in third place.
So that means he definitely goes right there.
So you've got them all in the correct line?
Yes.
All right, let's take a look and see if you've got it. So we've got Einstein, Rover, Spot, Buffy, Shadow. Nicely done. All right, congratulations on that. For doing some great work so far today, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that.
Thank you.
Have you ever been to Chick-fil-A?
No.
No? Oh
No.
my goodness, you're going to go to Chick-fil-A and you're going to go, oh, what have I been missing right there? So when you go to Chick-fil-A, if you remember this, go in and ask for Troy. Troy is the guy that runs the Chick-fil-A.
Okay.
And tell him that you were on Do the Math because he loves Do the Math. That's why he gives you guys free meals for coming on the program.
Okay.
And that way you can talk to him about anything you want to. Sound good?
Yes.
All right. You ready to do another math problem?
Yes.
That's exactly what I wanted to hear. So let's take a look at the Elmo once again. So you know place value, correct?
Yes.
Like ones, tens, hundreds. Do you know numbers after decimals, what those place values are called?
Yes.
What are those? Do you know?
Yeah, we got tenths, hundredths, thousandths.
Good. So that's probably all you need to know right now.
Yes.
Okay. So let's take a look at the problem together. My tens digit is one more than my units. I am odd. I'm divisible by 5. Who am I? So you and Cindy start thinking about this. What? You guys write down whatever things you think you need to know.
So tens and units would be ones, right?
Yes. So let's see.
Okay, my
So it
tens
says my
digit
tens, yeah.
is one more than my units digit, so I'm just gonna write that down because it's hard to see. All right, and
Okay, and it is an odd number.
divisible by 5.
Okay. And has to be divided by, it can't be divided by 5.
All right.
That's a
All
lot.
right, so we know, it has to be 1 through 9 or 0. I guess it could have a 0.
Yeah.
Maybe.
Let's see.
Probably not, though, because it's one more than that. So, all right, so the tens digits, so we know these are only one apart.
Yes.
We know it's odd, and we know it divides by 5.
And it makes it easy.
What do you think's a good one to start with?
We can list the odd ones and then see which ones can be divided by 5.
How about we list the multiples of 5 that are odd? Just because there's less of them.
Yeah.
So 5's only a 1 digit. So just like, okay, we got 5, then what?
Then would be 10, but that's even. So
Yeah, and we know 5 can't be it because it's 1 digit.
Yeah.
So 15.
Yes.
All right.
And then after 15 would be 20, but that's even, of course. So
All right, you want to continue this?
Yes.
So what will be next?
25.
And you can write down here, too, it's fine.
And then after 25, it would be 35. So we're pretty much adding 10 each time since these are the only ones that are.
Yeah, and we're just trying to do it until we get to where they're only 1 apart, right?
Okay.
Okay.
So then we can, let's see, do 45.
Okay.
And then 55.
All right, so let's stop for a minute and look at what we got so far. Are any of them so that the tens is 1 more than the units?
No, all of
Not
them
quite,
are
right? That's 1 apart, but not in the right way.
order.
Okay, so we got to keep going.
Then it's 65.
Okay. And
then after that, it's 75.
so do we have the answer yet, though?
I think so.
Which one?
65.
I agree. So we think it is 65.
So that's the first part of the entire.
You guys going with 65?
Yes.
Are you positive it's 65, or you just think it's 65 because that's the first one you came around with?
65.
Could it be any other number? Because you stopped at 75.
Could it be? Aren't they
Could
just
there
gonna
be
get
another
further
possible
apart?
answer for this?
Don't think so, because 6 is the only one that's 1 more than 5.
What are the other numbers that are divisible by 5 that are odd, where the tens is 1 more? Any other? What if you kept going by the tens like you were doing? What else would come next?
So what would be next, right here?
85. And then after that, 95. And then after that would be 100, but we can't do that, so 105.
And then we're out of the 2 digits, right? So
Yeah.
that's as far as we need to go, and that's the only one there is, and there's nothing else divisible by 5.
So
yeah.
let me throw this one at you. What about 87? Write 87, because how many things will that satisfy?
Out of our
There's-
3 clues.
Because you have 3 things. If I had 87, would it satisfy any of those 3?
Only odd. That would be it.
Would it satisfy this?
Oh, yeah.
Well, how about 87? Can you divide it by 5?
Nope.
Evenly?
Nope.
No, I'm only kidding. I'm just throwing you right there. Nicely done. So, Brianna, come on over here. I've got 2 more things for you.
Okay.
So, first of all, did you learn a little bit of something today?
Yeah.
Good. Did you have fun today?
Yes.
That's the important thing right there, all right? So do remember we have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.